Do you know what Ireland's biggest export is? Many people are surprised to hear that Ireland is the largest net exporter of pharmaceutical products in the world. We're home to 120 pharmaceutical companies who together produce 50 billion euros worth of pharmaceutical products, which is 50% of Ireland's export market. This makes Ireland a unique place to interact with pharmaceutical industry and to conduct pharmaceutically relevant research. My name is Denise Croker, and today I'd like to share with you my experience of being involved in pharmaceutical research at the University of Limerick. I work with a research centre called the Synthesis and Solid State Pharmaceutical Centre, or SSPC. The SSPC is a research partnership between pharmaceutical industries and academic centres across Ireland and with international collaborators. So together we work on trying to advance pharmaceutical manufacturing processes. My own experience is based in something called API manufacturing, and I'm going to talk to you a little bit about what that involves. We're all familiar with pharmaceuticals or with medicines. Take a tablet if we're not feeling well. So that tablet is composed of two main things. You have an active molecule that actually works to make you feel better. This is called an active pharmaceutical ingredient. And then we have a range of other materials, collectively known as excipients. Now they're there to provide bulk to the tablet, to help control the dosage and to improve processability. The actual manufacturing process mimics these two materials. Okay? So our API material is manufactured in one stage, and then it is combined with the excipients in a separate stage, which is often in a separate facility or separate factory altogether. For the SSPC, we conduct research across the entire process, but for me personally, I look at a specific part of the API manufacturing process. That's called crystallization. Now, crystallization is the isolation of your solid product, or solid molecule in this case, from a liquid or a solution. The crystallization process can impact the actual properties of the material that you isolate from it. Now, what we're interested in the pharmaceutical industry would be the shape of the material, the size of it, and also the actual physical form of it. So the product of a crystallization process is a crystalline material. And what do we mean by that? Crystalline material has a regularly repeating internal pattern in its structure, so it's known as a crystal structure. The crystal structure of the material then imparts certain physical properties to that material, things like solubility, density, melting point. So with respect to pharmaceuticals, the solubility is very important, because when we take a medicine, it needs to dissolve in our body so it can have an impact and let us feel better. So there's a whole area of research dedicated to looking at the products of crystallization processes and trying to understand how the actual conditions of the process impact your final product. One particular area is something known as polymorphism. So polymorphism is when a material can have a number of different crystal structures, so a number of different internal patterns in its solid form. This is important because each of those different crystal structures will have a different set of properties, for instance, different solubilities, so they will act differently in the body. Normally, the actual process is designed to only isolate one of these polymorphs. That's going to be the saleable form. It can be complicated to actually isolate just the desired polymorph from a system. So if a compound has a number of different polymorphs, they'll all have different stability. One of them will be stable, the rest of them will be metastable. And in a process, such as a crystallization process, when you're trying to isolate these materials, they'll tend to transform, to want to transform to the stable form. So here in UL, we do research looking at the rate of polymorph transformation, what impacts polymorph transformation, how does the crystallization process actually impact the polymorph that you isolate. This is very relevant to the industry because every pharmaceutical industry will have a crystallization process in its manufacturing system. So we work with the companies to investigate industrial compounds and also model systems to try and elevate our understanding of polymorphism and how it impacts pharmaceutical manufacturing. Another area of interest for us relates back to the overall manufacturing system. So as I mentioned earlier, the process is normally split, so you make your API material and then you formulate that into a drug product. Now these two different facilities could be separated by continents. Sometimes you'll make your API, ship it, pack it up and ship it off to another place to be formulated. So you can imagine this results in loss of time, in costs, and if we can actually make everything in one facility, it would be a lot more efficient. So some of the research we're looking at now also involves tailoring your crystallization process to make a product that is suitable for direct formulation into your final medicine. An area that's interesting in this is something called continuous processing. So traditionally in the pharmaceutical industry, we make batches of products. So we take our reaction vessel, we fill it with our reagents, cook the reaction over a certain amount of time, and then isolate a batch of product. The opposite of that really is continuous manufacturing, where you continuously feed a reagent stream to a vessel, the reaction is continuously occurring in real time, and then you isolate a product stream continuously also. So there's a number of benefits to this in that it normally involves lower capital cost to set up your process. It also can work a lot more efficiently. It can give you very consistent product quality. So instead of having batches of different products, you now have one continuous stream of product coming off your system. So this is a really interesting area for the pharmaceutical industry. I'm currently setting up a project with 2 pharmaceutical industrial partners to look at this continuous manufacturing of pharmaceuticals. We're specifically going to look at the crystallization process I spoke about and associated downstream activities like the filtration of your product and the drying of the final crystal product, and looking at how can we make these materials continuously. So I hope I've given you a flavour of the type of research we do here in University of Limerick. If you'd like to see more, we'd love to have you visit us or check us out at ul.ie or sspc.ie. My name is Denise Croker and I'm for UL.